Yes, welcome to DC Economics. So today we are going to look on on convex and concave function. So what you need to understand that for any monotonic function, we know that the function increases or decreases, but we actually do not know whether the function increases or decreases at the increasing rate or at the decreasing rate. So the sign of the second derivative that you obtain show it exactly. Now, because we are focusing on looking on convex and concave function, we need to understand what is about convex and concave. Now let's begin with concave. So we actually begin with what is known as a convex function. What is convex function, by the way? So under what is known as convex function, what you need exactly to understand here, if the second derivative, of a function of x is positive, this means that the function is said to be a convex function in the given interval. So if the second derivative, of a function, that is function of x, is positive, for example, we may write like this: the function of the second order derivative is greater than 0. So this implies that the function is convex in the given interval. So what about concave function? This is about convex function. What about concave? Now let's look on concave. So under concave function, what you need to understand exactly that under concave function, if the second derivative of a function of x is negative, so this implies that the function is said to be concave of a function in the given interval. In the given interval. So if the second derivative of a function of x is negative, let's say less than 0, then the function is said to be concave in the given interval. Graphical, you may display the concave and the convex function as this. So let's show it graphically. So graphically, you can sketch something like this, as you observe. So this is 1, this is 0. So under convex function, when the second order derivative of the function is positive, then the function is said to be a convex function. This means that displays goes exactly as in a positive relationship, like this. So actually this is y. So this is y and this is x, as observed. And side of negative, it go exactly like this. So actually this is convex function, display the convex function. So when second order derivative give out a function which is equal to positive, this implies out a convex function. But also, what about this? On the right hand side, this is what is called the concave function graph. As displayed, when the second order derivative is negative, this display the function will be going in this direction, as observed. Now, after looking, so let's look at an example. Now, for example, example number 1 show that the curve of y is equal to 2x minus 3 plus 1 over x is convex from below for all positive value of x. So show that the curve y is equal to x minus 3 plus 1 over x is convex from below for all positive values of x. Now solution. So we require to show how it is the curve is convex. I hope you know the convex condition is that the second order derivative, when it gives out is positive, we conclude that that is a convex function. From this function now, provided this function, so this is, this is below x, so we conclude that this is x, 2x minus v plus 1, that are x convex from below of all positive values of x. So you may consider to sketch out the graph like this. Let's put it in the minimal right hand side like this. So this is one this is 1 over x. X is standard this middle points here. So convex from below all positive values of x. So solution from this kind of derivative, it will be now y is equal to 2x minus b plus 1 over x. So we apply the first and the second order derivative, that will be dy over dx. This is the first derivative of the function. While different, it will be 2 minus. It will be 2 minus. This will consider to take out, it will be 1 over x squared. Since when we apply the quotient rule, in solving not 1 over x squared, remaining with 1 over x squared, as we observe, for the first order derivative of the function. So this will consider. So you may like to know that we have take out 1 over x squared. Now where that does 1 over x squared be obtained from this kind of function? When we apply the first derivative function from this function, it will be equals to 2. Now 1 over x squared has been considered as putting out 1 over x into inverse. So when you put out, take out to consider the 1 over x, you apply the derivative change of the function. Put it in inverse to be x, that is equal to negative 1. So let you take out the negative 1, then you minus negative 1. So this, when you take out negative 1 minus negative 1, is where you obtain the x base power. Is where you obtain out negative 2. So when our function will appear to negative 2 like this, we change this, we apply what is known as a power law after changing the inverse function, so as we can obtain the second order derivative of the function. So when we apply the power law function here, we extend the denominator value, the upper side. So this denominator side comes this way. This will give out a function like this. So when we apply the second order derivative, we derivatize again this function. So it will be negative 2x. It will be negative times x is equal to negative 2x. Then raised power of negative 2 minus 1. So when you take out negative 2, then you minus 1 as a condition for derivative, it will be negative 3. So it will be negative 3. So it will be 2x times x raised power of negative 3. So we change out the denominator value. Since here we have negative and negative, so this will come this way, the upper side. That will give out what will be as dy raised power of second derivative is equal to. So it will be in negative 2 over negative 2 over x raised power of cubic. So here we had the negative. When you put we had negative, negative and negative cancel becomes positive. So it will be dy square over dx square is equal to 2 over x cubic. Now since we obtain our x 2 over x cubic by applying what is known as a power law, now we may conclude that from our function, we may conclude that since our second derivative of this function 2 over x cubic is greater than 0, so the curve is a convex from below all positive values of x. So we may consider that since the values of 2 second order derivative of the function is 2 over x cubic is greater than 0, so we may conclude that the curve is convex. So the curve is convex. So we may say that the curve is convex. The curve is convex from below for all positive values of x. For all positive values of x. So let's consider another example. Now suppose we have another example over here. Another example. So we have show that the demand curve P, which is equal to 10 over x plus 5 then minus 8 is downward sloping and convex from below, convex from below. So that's the question. Now let's go to solution. Now the condition here, we are required to show a demand curve that is P is equal to 10 over x plus 5 minus 8, that is a downward sloping and convex from the below. Now condition for convex is that the second order derivative, if it is positive, that implies that it is a convex function. If the second order derivative is said to be a positive, then that implies that this is what is known as a convex function. Now for that case, we need to apply the quotient rule so as we can solve up the value, in either manner that we can determine the function. Now let's solve as follows. So this 8 is not a subset of the question. So let's consider the following. So how could we solve this kind of question? So we have first to find the first order derivative of the function. So in order we can solve out the first order derivative of the function 10 over x plus 5, we need to apply what is known as the quotient rule. That is dy over dx is equal to. So we apply what is known as a quotient rule so as we can solve the first order derivative to prove out the convex function. So dy over dx is equal to, so we take out dy over dx, that is equal to v times du over dx minus ud v over dx. Now here, this is our u and this is our v. Now from this kind of function, we have now a u which is equal to 10, that when we apply the dv du over dx, here is equal to 0. And we have v which is equal to x plus 5, x plus 5. So since we have x plus 5, as you observe, now the equation tends to obtain to give us the function, that is, we apply the derivative change of dv over dx. And since our x plus 5 is raised power of 2, is raised power of 2 as you observe, and this is raised power of 2 as you observe in our equation, that the equation of x plus 5 was raised out of 2. So when you consider to take out the dv over dx, that will be equals to 2x. That will be equals to 2x. Then it will be 2x raised of 2x, then plus 5. This like to say it will be out 2x. When we take out the figure over there, it will be 2x plus 10. That is 2x plus 10. Now for that case, now we plug into our formula. Let's take it to our formula. This is like to say that when we apply the derivative, this will cancel because it is a constant, so it will remain with 2x. So when we take out our dv dy over dx will be equals to, and we take out our v. This is our function of v we have is x plus 5 raised power of 2, then times du over dx. Now our du over dx is 0, so we times 0 minus our u, our u is 10, then times out our dv over dx, which give you times 2x, which is equal to times 2x. Then over, remember our function is divided by v square, so we need to take out our v square. What our v square is x plus 5 raised power of 2, so we raise again raised power of 2. So our function of dy over dx will give us the function here will be 0, so it will be 0 minus this figure here. So 0 times this figure here is equal to 0. 10x times 2x is equal to 20x, so it will be 20x as observed, over times by raised power of this function, it will be out x plus 5 raised power of 4. So this would be the answer for the first order derivative of the function. Now after taking the first order derivative of this function, what is next? Now we need to find the second order derivative to prove that if it is convex or concave. If it is a convex function, the second order derivative of the function must be positive. If it brings the results of positive or greater than 0, then the function will be said to be a convex function. So let's apply the second order derivative of this function. So when you apply the second order derivative of this function, it will be dy square over dx square. This will give out the second order derivative of this function will be equals to 20 over. So this will be equals to 20 over raised power over x plus 5 raised power 3. And actually, this has been obtained in the first order derivative of the function, that is dy over dx, that is equal to 20x over x plus 5 raised power 4. So actually, this function, so since now our second derivative of the function, is actual 20 over x plus 5 raised power of cubic. So since this answer is positive, so the demand curve, So the demand curve is convex from below. So that is actually how we check out for the convex and convex function. I hope that is clear, and thank you for watching. So welcome to DC Economics. Don't forget to subscribe my channel and get more favorable videos. Bye bye.